Hello guys, I hope you all are doing good. I'm Vaishali Kikan and we are discussing the electronics engineering. Today we are moving on towards the next application of the diode, which is the clipping circuit. So diode can be used as a clipper. So first of all, we should need to know what is a clipper, right? What it needs to do in our circuit, and then we will move towards different types of the clipper, and then we will be seeing the different types of the clipper in detail, their circuits and their operation, and at last we will see the application of the clippers. And this is how we are going to proceed in this lecture. So let's start our discussion with the introduction to the clipper. What is clipping? Clipping means the removing some part of the signal, right? So waveform here is shaped by removing or clipping certain portion of the input voltage, right? So let's suppose I was supplying the input voltage from +5 to -5, but I need to have the output voltage in between 1 and -2 only, so that I can do with the help of the clipper circuit, right? It is going to clip the output in between the desired levels, and above and below a certain specific level I can clip off my input voltage with the help of the clipper circuit. So isn't it interesting? This video is going to be really interesting and informative, and I hope all of you are going to prepare your notes with me, because this is how you can remember the circuits, right? So we are going to talk about a lot of types of clipping circuits: positive clipper, negative clipper, bias clipper, and the combinational clipper. Now, what is the alternate name of the clipper? So clipper circuit is also known as the amplitude limiter, because we are limiting the amplitude of the voltage or current in the desired level, right? So it is also known as amplitude slicer. We are cutting the upside or below amplitude, right? So this is the reason we are calling it as amplitude slicer or amplitude limiter. So now coming to the various types of the clipper circuit, we will see all of these types in this video itself, and we will see their operation, circuit in the detail as well. First of all, let's talk about the positive clipper. As the name suggests, the positive clipper is going to clip off the positive half cycle, right? What we have at the input, we will be having a sinusoidal wave. So now the sinusoidal wave will be having a positive half cycle and the negative half cycle. If I want to block the positive half cycle, I will be using the positive clipper. It will not pass the positive half cycle, it will just pass the negative half cycle. I hope you remember the rectifiers. There we were doing the opposite. We were just passing the positive half cycle and we were blocking the negative half cycle, right? This is the opposite. So now in the positive clipper, we are clipping off the positive half cycle of the input signal, and what we are using for that, we are using the switching property of the diode, which is similar to the half wave rectifier, right? So what is the switching property? The diode will be behaving as a perfect conductor in the forward bias and as an open circuit in the reverse bias. We all know this thing. So the direction of the current will be unidirectional through the diode, and this property we are using, right? So the diode is having the non-linear characteristics, and because of this it can be used as a positive clipper. So it is an important part of the clipper circuit. So now for the positive clipper, we have two types: positive series clipper and positive shunt clipper. Now coming to the positive series clipper. So here the diode is connected in series, right? So now you can consider the diode as an arrow. So what is the direction of this arrow? The direction of this arrow is reverse, right? So it is in the backward side, so it is going to clip off the positive side. It is going to just transmit the negative half cycle. So this is my input waveform. Here we have diode connected to the resistor in parallel, and from the resistor we are going to take the output voltage, right? So now the output voltage will be having just the negative side of the waveform, not the positive side. So how it is done? What is the operation of the series positive clipper? So let's understand this. So when we have the positive half cycle, here we are applying the positive terminal. So when this is my input voltage Vi, right? So we are having the positive terminal over here. When we have the positive terminal of the battery over here, it is connected to the N side of the diode, and diode will be having the reverse bias. In this case, diode will be behaving like a reversed bias circuit, and it will be an open circuit now, right? So when it is an open circuit, no current will flow through this circuit, and we will not get any voltage across the resistance, because when we have zero current across the resistance, resistance, the voltage would be 0. So during the positive half cycle we will be having the 0 voltage. Now in the negative half cycle we will be having the negative voltage over here, and the diode's N side is connected to the negative voltage, and due to which I can say the diode is forward biased and diode will behave like a perfect conductor, and the current will flow through the circuit, and the output will be half sinusoidal waveform in the negative side. And here I am considering the diode to be ideal, because when the diode is ideal I am not considering any leakage current, right? I am not considering any on voltage. So I hope you understood the positive series clipper. Now moving on towards the positive shunt clipper. In the positive shunt clipper I will be placing the diode in the parallel. You can see the diode is placed in the parallel. This is my input voltage Vi, right? So when we have the positive half cycle, here we will be having the positive side of the battery. So when the positive side of the battery is connected over here, so the diode's P side is connected to the positive side of the battery, and the diode will be forward biased in this case, right? So diode is when forward biased, the current, all of the current will pass through this, and when all of the current is passing through this, we will be having the output V output to be across this terminal, because the output voltage is parallel to the voltage across this side, and if I take this voltage of this side, it is 0 because there is no voltage drop, there is no resistance. I am not considering any forward resistance of the diode, so here we will not be having any resistance, so we will not be having any voltage drop, so V output is 0 in this case. Now in the negative half cycle, diode is reverse bias. You can see here we have the negative terminal of the battery which is connected to the P side of the diode, so the diode is reverse bias, and when the diode is reverse bias, the resistance across the diode will be very high, right? So resistance across diode is very high, it will be behaving as an open circuit. So all of the voltage drop will be occurring at this diode only, or I can say this is open circuit, so the output voltage is parallel to the input voltage, so input voltage will appear at the output voltage because no current is going through this branch, right? So V output will be equal to V input, right? What was there in this case for the negative half cycle? When I had the negative half cycle, diode is forward bias. Now full current is going to flow through this circuit. When the current was flowing through the circuit, so we were having the positive voltage drop across the resistance, and when we had the only drop, the input voltage is going to drop across this resistance only, right? So input is going to be appearing at this resistance, and V output will be equal to V input, right? So this is how also we can assume the operation of positive series clipper. So now coming to the negative clipper. Negative clipper, as the name suggests, is going to clip off the negative waveform. Negative half waveform is clipped off with the help of the negative clipper. Again, we have the two types of negative clippers, negative series clipper and the negative shunt clipper. What is the negative series clipper? In the negative series clipper, we are connecting the diode in the series to the input voltage. So you can see here, this is my input voltage. In the output, we are not getting the negative side of the waveform, we are just passing the positive side of the waveform, right? So this, when we consider this to be an arrow, the diode is connected in the front side, right? So the diode is connected into the front side, which means we are going to send only the positive half cycle. So let's understand the operation. So when we have the positive half cycle over here, the positive half cycle is connected to the P side of the diode. Diode will be behaving as a forward bias circuit. It will be behaving as a perfect conductor, and all of the input will be appearing at the output. So all of the voltage drop will occur at this resistance, the current will flow, and all of the current will be appearing as a input voltage across this resistance, right? So V output will be equal to V input. And during the negative half cycle, when we are supplying the negative voltage over here, the diode will be behaving as an open circuit. No current will flow through this circuit, and when no current will flow through this circuit, what will happen? We will not be having any voltage drop across this R, so V output will be nearly equal to 0. Now coming to the next type of negative clipper, which is the negative shunt clipper. Here we are placing the diode in the parallel to the input voltage. So this is my input voltage. We are clipping off the negative side of the waveform. Diode is placed in the parallel and the direction of the diode is upside, which means we are sending the upside signal, the positive half signal. In this case, in the case of positive shunt clipper, the diode's direction is downside, which means we are sending the downside signal, the negative half signal, right? So let's understand the operation of this clipper. So this is the input waveform, how we will be getting only the positive part of the input. So when we have the positive half cycle, you can see diode will become reverse bias. This is N side, which is connected to the positive side of the battery. Diode is reverse bias, so this will be an open circuit, or we can assume it as a very high resistance. So all of the voltage will be dropping across this resistance only, right? This resistance is very small in comparison to this resistance in this case, and or I can assume this to be an open circuit. When this is an open circuit, no current will flow through this device, and when no current is flowing through this device, we will be having input voltage appearing across the output, right? So we will be having Vi is equal to Vout. So now coming to the negative half cycle, when we have the negative voltage over here, negative voltage is connected to the N side of the diode. So diode will behave as a perfect conductor. It is forward bias, it is perfectly conducting. So now here V output is parallel to this branch. This branch will be having the zero voltage drop and V output will be equal to 0. So in this manner, in the negative half cycle, we are getting the 0 volt, but in the positive half cycle, we were getting the V output is equal to V input. Now coming to the bias clipper. Till now we were clipping off the full positive half cycle or full negative half cycle. If I want to clip off from plus to upside half cycle, right, from plus 5 to plus 2, I don't want the input waveform, but from plus 2 to minus 5 I want it, right, when the input was plus 5 to minus 5. So how I can do this? With the help of the biased clipper I can do this. So it is going to adjust the level of clipping to a certain level by adding a bias voltage. All I require in addition to the clipper circuit is a biasing voltage, whatever voltage you want to bias at. So let's suppose you want to bias at plus 2, the forward bias, so you will be taking a voltage equal to 2 volt, right? So you will be requiring a bias voltage which is equal to the required voltage, and we will be placing it in the series with the resistor. So here you can see this is my bias series negative clipper. In the negative clipper only, the diode's direction was in the forward direction, right? So here we have to place the VB in the parallel branch. Here it is in series with the resistor. Here we can place it in the series with the diodes. This is a bias shunt positive clipper. So let's understand how the biasing happens with the help of bias shunt positive clipper. So we will be applying VB, and above VB we will not be having any input waveform. We are clipping above VB, right? So we are going to do that with the operation of this circuit. So when I have a more positive voltage at this terminal than VB, so let's suppose you put VB is equal to 2, right? So here we will be having 2 volt, and here let's suppose we have more positive voltage than 2. Here let's suppose we had 3, 4 or 5. So when we were supplying the more positive voltage over here, this diode will be forward biased, because here at the P side we were getting the more positive and at the N side we were getting the more negative voltage. So the diode will be forward biased, and when the diode is forward biased, at the output what I am getting? I am getting just the VB, right? So output will be equal to VB only when I have the more positive voltage. Now let's suppose we have the negative voltage. So let's suppose instead of 3 I will be having the 1 volt over here. So this side will become more negative as compared to the 2 volt. So now here we will be having negative side connected to the P terminal and positive side connected to the N terminal. Diode will behave as a reverse bias circuit, and the input will appear across the diode. So when the diode is a reverse bias, this circuit will be opened. So no current will flow through this branch, and the input will directly appear across the output, and V input is equal to V output. So we will be getting the same signal when we have the voltage lesser than VB. So when I was having 1 volt, 0 volt, -1, -2, so at every time I was getting the same voltage at the output, but when Vi is greater than Vb, we were limiting the output at Vb only. So this is how our bias clipper is going to work, and if I reverse the diode direction, it is going to clip in the negative direction, right? So you can reverse the diode direction, you can put the diode in the upside direction, it is going to clip in the negative side. So now coming to the combination clipper. Right, so in the combination clipper, what happens? We are just clipping in the bias clipper in the positive half cycle, or we can clip in the negative half cycle if I need to clip in the both of the cycles. So if the input is +5 to -5 and I want output from +3 to -2, so I am clipping the input both of the directions. So what I can do, I can connect both of the directions of the diode. So if I connect the diode in the downward as well as upward direction, so I will be having the combinational clipper. So here we can put VB1 and VB2. So when the diode is in downward direction, it is going to clip off the positive half. So above the VB1, it is going to clip off all of the positive cycle. And when the diode is in upside direction, it is going to clip off the negative half. So below the VB2, it is going to clip off. So now when I have the positive input voltage, so at that time, diode D1 will be short circuit and diode D2 will be open circuit. Diode D1 will be forward bias when I am supplying the positive voltage over here. If I have the voltage which is greater than Vb, more positive than Vb, so diode D1 will be forward bias and full current will pass through it and output would be Vb1. When I have more negative voltage than Vb2, so at that time what will happen? If I have more negative voltage than Vb2, so diode D2 will become forward bias and at the output we will be having the current flowing through this branch only. Diode D1 will be reverse bias, no current will flow through this branch, all of the current will flow through this branch and V output will be equal to VB2. In between this, what will happen? If I have Vi lesser than VB1 at that time, the V input is traced at the V output. And again, if I have V input greater than -VB2, then also we will be having V output equal to V input. So this is how we can understand the combinational clipper. In the combinational clipper, we can adjust the voltage in the desired level. Now coming to the applications of the clipper. Now clippers are used for the various purposes. First, it is used for the circuit transient protection. So when I am using the clipper, I am going to clip it in the desired level only. When the transient is occurring, it will be a very high voltage. Now I have clipped the voltage in the desired level. Very high voltage can never be occurring at the output. If I have a very high voltage at the output, it can damage my devices. So I can protect my devices with the help of clippers. It can change the shape of the waveform that we have already seen. So I hope you understood each one of the things that I have discussed in this video. If you have any doubt, you can put the doubt in the comment and I will be trying to resolve your doubt as soon as possible. I hope you like this session. If you like it, please push the like button, subscribe to the channel, share it with your friends and also give me your feedback. Thank you so much.